think he's got 110.
Okay, I'd like to welcome everybody to this year's Oliver Smithies Symposium. As many of you know, but for those that don't, Oliver was a faculty member in the genetics department for 25 years, and it is through his generosity that this symposium was established. This is not moving forward. It's not moving forward. Right? So that's not doing anything either. So Oliver is really known scientifically for 3 sets of work that occurred over. What did you do?
I just clicked on the screen.
Okay. 3 sets of work that occurred over his career. The first sets were in the 50s, where he worked on blood proteins. And the second set involved a collaboration with Fred Blattner here and involved software for sequence analysis back in the day when sequence analysis was extremely difficult to do. And then finally, of course, the work that led to his being awarded with the Nobel Prize, which was genetically manipulating mice. Now, there's a number of characteristics of Oliver. Anybody that's met him, I think, would agree with these. First, he was extremely big proponent of good science. And he writes about his PhD work with Sandy Ogston, who was a biophysical chemist at Cambridge. And Oliver says that that was among the most satisfying pieces of scientific work that he did, even though that paper has never been cited by anybody, including Oliver. So it's sort of interesting. And one of the points he makes in his writings is that he learned from that completing experiments all the way to the end, no matter how much work was involved, no matter what your perception of the goal of the reward, the publishable reward, would be. So that's something that Oliver developed early on and kept throughout his career. The second thing is Oliver is very passionate about science. And there are quotes, again, in his writings and in his talks about the fact that graduate students, especially in postdocs, should be really interested in what they're doing. And he goes so far as to say, you know, if you're not, you should change projects or change advisors. And I was a graduate student here in the early 80s, and Oliver taught the eukaryotic molecular genetics course, and I was fortunate enough to actually take that course. And what I remember from that course is he was always just a tad late to class. He would come running in, he would have this stack of Xeroxes. There were about 20 people in the course. They would be divided into 20 divisions. There would be about 6 or 7 papers for everybody. So you have 20 packets. And he would hand them out and then talk about them. And they were invariably recent, new papers. The Xeroxing was still warm. The papers were still hot, literally. And Oliver just said, these are the most interesting papers I've seen recently. And he would talk about them. And that kind of spirit certainly ran through his whole research life. Along the same vein, Oliver took teaching very seriously. And you can see his attitude about teaching. And now, with the luxury of time, I can think back and I realized that in that course, which I think was 1981, Oliver was already thinking very seriously about gene knockout technology in mice. And a large fraction of the papers that he handed out and talked about were on that subject. Finally, Oliver has this wonderful description of the aha moment. So Oliver was a pilot, or is a pilot still, and he characterized flying as a sort of an analogy for doing science, saying that it's not learning to fly, it had a huge impact on him, and it's not learning to fly, it's learning to overcome fear through knowledge. And he describes in his writings also about the moment he was standing in the darkroom developing the autoradiograph that had the evidence that insertion had happened, the knockout, in mouse. And he likened it to the runway moment, this thing where you break through the clouds and the runway is right there. And that I think captures very well the spirit of Oliver and also the way he taught in that course. So before our speakers today, I just want to acknowledge people that helped finance this. First and foremost, of course, is Oliver, and then these are the units in the university that make this responsible. Before I introduce our first speaker, I just want to say, take a moment to acknowledge for all of us to remember Tony Pawson. Tony was originally one of the speakers that had said he would come, but of course passed away last fall and was a seminal figure in this field of signal transduction.